In this episode of TLDR Year 12 Physics, we're covering friction and motion on inclined planes. Before we discuss how objects move on an inclined plane, we must first learn about friction. There are two types of friction, static friction and kinetic friction. Static friction is the frictional force which must be overcome to make an object initially move. As soon as that object begins to move, kinetic friction takes over. Kinetic friction is the continual frictional force which must be overcome to keep that object moving. We can look at this graphically. Initially, our static friction resists the force which is applied to the object until the threshold of motion is reached. At this point, the kinetic friction takes over and the frictional force required to sustain motion becomes less than the static friction we needed to move it initially. Both kinetic and static friction are characterized by frictional coefficients which can be called μk for kinetic friction and μs for static friction. They're dimensionless numbers, so they have no units. Now the frictional force is equal to the coefficient of friction multiplied by the normal force acting on the object. Now you've probably come across the term normal force before. It simply refers to the component of the total force applied to the object that acts in the direction perpendicular to the plane in which the surfaces are in contact. Now that's a bit of a mouthful, so let's just have a look at an example. For an object sitting on a flat plane, the normal force is simply equal to the weight of the object. This is because the object's weight force pressing down on the flat plane is already perpendicular to where the two surfaces meet. Now, if we look at an inclined plane, which is simply a flat plane that has been tilted by a certain angle, the weight force, which always acts directly down, is no longer acting perpendicular to where those two surfaces meet. For this reason, the normal force will only be a component of our total weight force. Now, in the last episode, we discussed how to resolve vectors into vertical and horizontal components. To solve questions where objects are on inclined planes, we must always resolve the weight force into a vertical and horizontal component along the plane. That is, we must find the force component which acts perpendicular to the plane, the normal force, and the force component which acts parallel to the plane, the net force, which will cause the car to move. We will now look at an example of a car resting on an inclined plane, but for the moment, let's assume that friction is negligible. Let's say our car weighs 2,000 kilograms and it's resting on a slope of 15 degrees. First, we'll draw a free body diagram of the situation. We know that the weight of the car acts directly down and the normal force acts perpendicular to the plane. The horizontal component of the weight force will be the net force in which the car will move parallel to the plane. So now that we have our free body diagram, we can calculate all the forces. Since we now have a right-angled triangle, we can solve using trigonometry. Since no friction is present, in this example, we're not actually required to find the normal force, as it doesn't contribute to our net force acting down the plane. We know from our free body diagram that the net force acting down the plane will cause the car to accelerate in the direction of the force. We can calculate this force, F net, as the weight force multiplied by the sine of our angle, which in this case is 15 degrees. So we know that net force is equal to the weight force, 2,000 kilograms multiplied by 9.8, multiplied by the sine of our angle, which is 15 degrees. We can solve to see that the net force acting down the inclined plane is equal to 5,073 newtons, or 5.07 times 10 to the 3 newtons, in three significant figure form, down the incline. We can now use force equals mass times acceleration. We know that our acceleration down the inclined plane is equal to force divided by the mass of the car, which is 5,073 divided by 2,000. This gives us an acceleration of 2.54 meters per second down the incline. Okay, to recap, today we've covered static and kinetic friction, as well as how objects move along a frictionless inclined plane. We will have a worked example video on this topic out soon. If there's something you'd like us to cover in the future, leave a suggestion down below. Thanks for stopping by and see you next time.